So before we continue with UI notifications and how we uh, implement the publish with observer pattern, it's best to revisit the basics first on how this actually connect to the wall, including how we would later use this in a real application and connect that into a real system flow. So let's just understand how these basics work. So this is exactly the piece that unlocks everything. References versus values, plus how memory is actually used, stack or heap, plus how React depends on it. So React is just a JavaScript library which we will further discuss in the future. Now let's build it from the ground up but keep it practical. Values versus references, the core idea. Value, copy the actual data, like let a equal to 10, let b equal to a, b equals to 20. So what happens? You copy a equals to 10, b equals to 20. They are independent because you copy another data in memory. Why? Because the value 10 is copied, not referenced to the same to the same data. So here reference, copy the address, let obj1 equal object name colon string Garrett closing, let obj2 equal obj1, then obj2 dot name is equals to John. What happens? Obj1 name is John, obj2 dot name is also John. So because you re-reference that, you're basically re-referencing referencing it in memory. So notice what how we code in the previous chapter, including all the design pattern. We are doing this re-referencing and copying values, etc. because we're following the underlying principle of stack and heap, which we will discuss further. Why? Because both point to the same memory. Now visual, this is the key. Value in stock, a is 10, b is 10. Reference in stock, obj1 0x001, obj2 0x001. So stock basically is how JavaScript and OS schedule what is being executed. So it's in CPU instruction or CPU architecture, which is the instruction pointer, the one we discussed in the previous video. So that instruction pointer determine how the code will be executed. So that puts into the stack. So it's highly related to how the code are positioned in your code, or where it is in your code, such as it is on the top or at the bottom. Because at the line of code at the top will be put on the stack first, and then after it is executed, then it will be pushed out to the stack. So it's the same what happens with JavaScript engine and with OS, which we will discuss further. So here in the stock, you can see it reference to the same object, which is an object or state or anything or any data that could be dynamically increased, or any data that is not fixed in size, such as like a primitive value such as strings or numbers, will be put in heap, because those are dynamic size, such as state or object. So the state and object, there's a lot of factors that determine that, right? Including the user input, how many state would be affected, etc. So here that in heap we have 0x001. That 0x001 is the reference memory address. Why this matters in React? React depends heavily on references. Example, state update, cons user comma set user equal use state, parameter name or parameter object with a member name and a value string a. So when we do user that name is equals to b, or when we like change the value of the name, it will provide us an error, and then If you use a set user with a parameter user, React does not re-render. Why? Because reference didn't change. It's still the same reference, still pointing to the same object. So it will run, but you will still get the same UI. So this will help us understand how the actual code actually works, or like change the actual value that we see on the screen. So correct way: set user parameter rest operator user comma name colon parameter string b. Now old object reference to 0x001, new object reference to 0x002. Reaxis reference change re-render. This is the rule. React doesn't check deep values. It checks references, identity. Second, stock versus heap, real understanding. Now connect this stock execution memory. It stores function calls. Store local variables, very fast, cleaned automatically. So this is kind of like where the instruction pointer of the CPU get its instruction that it will execute step by step. So this is the memory part. In the CPU architecture we have discussed in the previous videos. So it stores the function calls, all the functions that will be called. It stores local variables, very fast, clean automatically. Heap, data memory. So think of the stock is the functions. Okay, so the functions is necessarily just a program, or like an instruction. While the heap, you can think about that as the data, where the data lives, or where this function will be executed, such as stored objects, arrays, functions, dynamic size managed by garbage collector. So we will discuss garbage collector further in the future, because it's fundamental into the basics of how the JavaScript actually works under hood. And also it's important to realize that React is just a collection of functions. So as you can see, if React is just collection of functions, those function is this will be divided into a function calls that is put into a stock, and then the actual data in the functions here, which is data memory, and everything of and all of those syntax are just a way for us to express those functions that we will execute on data. And then example function test, inside is we have let x equal 10 semicolon, then let obj equal object name colon string a. So in memory we have stock. So the stock here would be the test function, and then x is to 10 because it's primitive, it's constant. Then the obj will store only the reference. So as you can see, the stock store a reference on our actual data. So how does it do that? Basically, in instruction pointer, or instruction pointer in what do you call this, in CPU architecture, there's a concept in which, like, if the I forgot what it's called, but yeah, it's a misprediction, or like it's like when you're pointing to something, such as there's something in prediction name where you will point to that part in the memory to access it. So those behavior are actually not, it's not as fast as a contagious memory, but basically that's how it works. So it executes this individual stock first in order of its execution, and then if the data is not available, it will this will reference to where the data is located in the memory, so that the CPU can go back there and jump there and get that data to be able to continue the execution of this instruction, which is the stock. So this is the heap 0x001 with an object name A. Now connect values versus reference, stock and heap. So for type, primitive, number or string, it's stored where? Stock usually. Behavior is copied. So for constant, the behavior is copied. So this is the difference between copied and reference. For object array function, it is stored in heap. So the behavior here is reference. So it's not really stored in the stock. It's just being referenced because it's too huge and it's dynamic. It's not a constant. So that's where you also get the constant and variable concept in programming language. So how OS actually allocates stock and heap? This is what you're really asking. When a program starts, the OS creates a process. It gives memory like this. Stock grows down. It grows down because the code starts again from the top. Then heap, we have code and data. So the data or code and data, is compiled to be able to get into this memory. So it is compiled from JavaScript to AST, and then that AST will be compiled to machine code the in-memory data structure, which is the stock and the heap, and that stock and heap will be the basis of the CPU to execute its instruction. So stock allocation automatic. When you call a function, like function add parameter a comma b and then inside return a plus b semicolon closing, CPU does first move stock pointer, and second store arguments and local variables. So it store that arguments and the local variable. So basically it use the stock to be able to do that. And then third, execute the function. So it will execute that function with since the CPU already have the arguments and the local variables or the code and data it needs, and then it will pop the stock when done. So it's very fast. For heap allocation dynamic, so here basically we just need to use a stock, right? For heap allocation, when you do let obj equals to the object name colon a, JS Engine ask OS, give me memory. Then second, OS find free space in heap. So the difference with heap is that the JS need to talk or to ask the OS to drop into the OS to ask for more memory, and it's also dependent on systems available memory if OS can provide that. And then it will return the address 0x001. So that's how you reference. The OS really provides that address to a process. That's also the same how we discussed the virtual and physical memory in the previous video. Important, you don't see this because JavaScript engine VH manages it for you. Fourth, garbage collector, very important. When object is no longer used, like let obj equals to parameter name colon a closing, then obj equals to null, heap still has it temporarily. So if we rename this object to null or undefined, the heap in a system still has that temporarily, and then it is garbage collected or garbage collected. So it's related to how the what we discussed with new map or garbage collected. The reason why it does this is for performance reason, so that it only needs to do this once instead of having to be able to remove that in each of those redefinition or redeclaration. Connect everything to React, now full connection. So we have const user comma set user equal use state with a parameter object name colon a. So we have in memory stock user 0x001. So it references that. In heap we have this name a, and then update set user name to b. So basically if we do this function, the instruction or pointer of CPU will basically execute or redefine that will create another. I mean, JavaScript is basically saying to OS to allocate me a new heap for this new object, because this function are setting this object to a new value, such as this 0x002 name colon b. So in stock user, it will reference now to 0x002. Now React compares 0x001 is not equal 0x002. Therefore, it will update now the UI instead of showing the same UI. So why this feels confusing? Because you're mixing three levels. First, syntax, what you write. Second, runtime, stack or heap. Third, system, OS or CPU. The clean connection, syntax to JS engine to stock or heap provided by the OS, and then to physical RAM. So final understanding, this is the click. Values versus references. Values equal copied data. References equal pointers to memory. Stock versus heap. Stock equal execution. Heap equal data storage. So stock is the instruction pointers, and then the heap is the data reference in the memory or in the disk, depending on where the data actually live. Actually, it lives in memory when we're talking about compiled code, because those compiled code lives in memory, and the data usually of that compiled code is in the database compared to the data being in the storage or SSD of a computer when we're talking about the process of an OS or the process of what we installed in our OS. So here React depends final answers, stock versus heap execution, heap data storage. React depends on reference changes, not deep value comparison. So it does not like create a new value, does not compare that. It only depends on reference changes. Like if the reference change, that's the only time it will update the UI. OS, it allocates memory regions. JS engine manages usage. So the OS, another thing is that it just allocate a memory to the JS, and JS engine still manages how it will use it. So one sentence to lock in. Objects live in heap. Variables hold references on the stock, and React decides updates by checking whether those references change. So let's see an example in real world of how it looks like in React. First, you cannot directly see stock versus heap in syntax. This is the root confusion. In JavaScript or TypeScript, there's no syntax like put this in stock or put this in heap. Instead, the engine or the JavaScript and the decides it automatically based on rules. So based on the JavaScript rules, or that like organized rules that allow us to, a good expression, like because JavaScript provide a good expression to like express that machine code, and then how the OS rules are imposed will determine how it is executed, or those stock and heap is executed. So simple rule, this will already help a lot. Stock, fast, automatic. Function calls, primitive values, sometimes optimize local variables. Heap, dynamic memory, objects, arrays. Functions, yes, functions are objects. So function is also object again in React. Those function components is an object. Functions is not different from object. It's still the same when we're talking about where it is being stored in memory. It's in heap and then a React state. So here in TypeScript, let x equal 10. semicolon. The next line, let user equal object member name colon string a. So those heap. So this let x equals to 10 is in stock, but more accurately, stock x is to 10, constant value, user. So the user on the left side of the operand is in the stock 0x0, it references 0x001, and in the heap is where the actual value. So you don't control it, you understand the model. Now, why React feels harder? You said React is harder because it mixes DOM, JS styling, correct? Because React sits on multiple systems at once. Full React execution flow, your exact scenario. Let's trace. You open your React plus TypeScript app deployed in browser, on Vercel. Browser loads your app. What happens first? Step first, HTML is downloaded. So moving forward in the future, we will discuss how, like in React, so the first few chapters in React, we will discuss how the React just carve out some initial HTML document and then impose all of its JavaScript on that small HTML document. So this is not actually the real representation, but it's good enough. So first, HTML downloaded, second, CSS downloaded, the third, JS downloaded. So the third step is JS. DOM plus CS SOM, HTML will be formed to a DOM tree. So that's the structure of your app. CSS is CS SOM. It's combined into a rendered tree. Important, DOM is not JavaScript. DOM is equal browser structure, C++ internally, JS interacts with it. JavaScript React starts running, now React runs, function app, inside return div hello, stock plus heap here. So render app is in the stock, the heap is the React elements or virtual DOM objects. So when we're talking about React in a browser, the render app or the like return the app is in the stock, and then the actual data or the is the virtual DOM element objects. Now React creates, so we have an object member type with a value div. So this is what's happening in the heap. The member it becomes an object with a member type, which is the div, and a member props, which is has an object inside. So this is an object inside object with a member children and as a value hello. So this is in heap. Third, React to DOM. React compares previous virtual DOM, new virtual DOM. So React compares previous virtual DOM, new virtual DOM. Then updates real DOM. So we have JS to DOM API to browser updates UI. So the React, it's still a JavaScript. It contacts the DOM API. So if something changes, that's the only time it will update the UI. Now the styling CSS. CSS is handled separately. That's why in React we only use, or like we only include the HTML in its JSX syntax with JavaScript. Browser computes the layout. It applies styles, it paints pixels. This is not in JS stock or heap. It is handled by browser engine C++. So user interaction event, user clicks button like here. Button on click equal handle click. So the flow, browser detects click, OS input. Second, event added to the queue, which is the kind of like the multi-level feedback queue of the JS engine. Third, event loop checks stock empty, yes, And then fourth, push handler to stock. So if the stock is empty, you put that into the stock for it to be executed by JavaScript engine. So push handler to stock, handle click function. Then 6, fetch request to Vercel backend. So after that, it will now contact the backend, fetch API/user. What happens? JS engine or JS app contacts the browser API, then the browser API or the browser contact the OS network stock, and then the OS contact the internet. Now your PC is talking to Vercel servers. 7th, Vercel Node.js backend. On Vercel, we use this line, export default async function handler parameter rec, res. Inside server, it runs on Node.js. It uses an event loop. So it's still JavaScript, but it just uses Node.js. This JavaScript just has an access to a network calls of your OS. It also has an access to a file system. So the stock of this is the handler function, and the heap of this is the request data comma objects, because this data and objects changes based on request. Asynchronous call in this is the DB call, await db.query. So it's sent to OS or network. So this await db.query, it's not in the memory of the Vercel anymore. It is being sent to its OS to be sent to PostgreSQL or Supabase. Now Node does not block. So the Node does not block. You just continue its execution with another stock. Then 8, database, Supabase, query executed, data return. 9, back to browser, response comes back, callback queue. So it will return to Node callback your stock. Event loop executes, and then it will return to browser, and then React updates the state if the reference change. Now where's OS in all this? OS is always underneath. OS responsibilities, memory allocation, stock or heap, regions, process scheduling, network communication, handling input, mouse or keyboard. Example, when you click mouse to OS, so the mouse contact OS first before the browser, instead of browser to OS to browser, then a JS event. After that, the browser will create a JS event and then create a stock, right? Based on our user input. So the stock is just like pointing to like a memory on the browser or on our code that we run in a browser. So event loop versus OS, important distinction. Event loop is equal JavaScript level scheduler. OS equal real system scheduler. Analogy, OS equal factory manager. Event loop equal worker queue. Now your real question, is this the basics I should revisit? Yes, but with the right depth. You should deeply understand mass master, stock versus heap, mental model, execution flow, synchronous versus asynchronous. So how the execution or flow in the stock are being executed within that layer or an outside layer. So that's the difference with synchronous or asynchronous, because for asynchronous, it's when you are talking to like a database, like a storage, or a network calls to another application instead of your own application, which usually is synchronous. Event loop, how tasks are run, references versus values. So the references versus values are the one we discussed earlier. So if it's constant, it's the value inside the app or in the stock. It's fast because the value already know beforehand. The references, usually those are the values that is not known beforehand. That's why we're referencing it to the heap. So don't over focus yet. OS thread scheduling internal, so you don't need to know this. Thread scheduling. CPU transistor level behavior. So when you're struggling, important insight, you're trying to understand all layers at once. Instead, learn like this. JX execution, stack, heap, event loop, then react on top of it, then backend, then OS awareness. Final mental model clean, user action to OS input, to browser to event queue, to JS event loop. So after browser, it just again it will not be executed immediately on the browser, but instead will be put into event queue because that's how the browser engine internals works, and then the JS event loop. So once it's in the queue, it will be put into it will be on the area, or it will be on the rules of event loop, and then call stack, functions run, and then heap, data stored, and then react updates UI, and then DOM na CSS render. One sentence to lock in, you don't see stack and heap in syntax because they are runtime behaviors, not language features, but everything you write ultimately maps to them during execution. So you won't be able to see the stack and the heap because those are the invisible layers we were talking about that we need to understand to be able to really understand how the syntax and features are works. So those are the fundamentals, but everything that you write in syntax ultimately maps to stack and heap, and ultimately must be compiled into machine code executed by instruction pointer, and must comply with the laws of OS, networking, and database. And we will discuss this in the future videos.